Doing Unit 5, Notes 4. So we are going to be talking about solving quadratics. So we're going to work through the different ways that you can solve quadratics. So let's go ahead and let's kind of remember some of the ways we've been solving quadratics in the first place. So basically three methods that you can use to solve quadratics. The first is graphing. So when you graph a parabola, if you think way back to the beginning of Unit 5, when you're graphing that parabola, where the parabola crosses the x-axis, which is, remember, is the horizontal axis, is your x-intercepts. That's also the solutions to the quadratic. So when you go through and you use the zero product property and the quadratic formula, that's what you're finding on the parabola are those x-intercepts. So the other next way that you can solve quadratics is using the zero product property and factoring. So that factoring, remember, is when we set up the big X. And then finally, the last way that we use probably the most is the quadratic formula. So if you look below here, you have a couple of things. So remember with the X, with the zero product property, a couple of things. First is that when you're looking at the top here, remember that that is going to be the product. So this is going to be the product. And then the bottom is the sum, and then on either side you're going to have your factors. Just something to keep in mind for that as we're going through and reviewing the zero product property. So what we're going to do is we're going to solve each quadratic, and we're going to use a couple of different methods. So the first one asks us to solve using the zero product property. Okay, so I'm going to set up my x. So I'm going to take my a and multiply it times my c. So 1 times 20 is 20. So I'm multiplying to 20 and adding to 9. So then I need to ask myself, what multiplies to 20 and adds to 9? Well, that's going to be 5 and 4. So I have x squared. And now, instead of writing 9x, I'm going to split 9x up as 5x plus 4x. That's what I use my x for. And you can see that that's still 9x. Plus 20 is equal to 0. So now I'm going to go ahead and factor this by grouping. Out of my first group, I can take out an x, and when I divide each term by x, I'm left with x plus 5. Out of my second group, I can take out a 4, and then I'm left with x plus 5. So I see left over, I have x plus 5. So I can go ahead and I can factor out x plus 5 because those are matching. So now I'm going to get rid of those, and in my other parenthesis is what was left on the outside, which is x plus 4. So that's the factoring part. So now to do the zero product property part, you're going to take each factor and set it equal to 0. So here, to solve for x, I'm going to subtract x from both sides. So I get that x is equal to a negative 5. Here, I'm going to subtract 4 from both sides. So I get that x is equal to a negative 4. So then your final answers when you use the zero product property are negative 5 and negative 4. So let's go ahead and take a look at using the quadratic formula to do this. Okay, so for this one, my a is equal to 1, my b is equal to 9, and my c is equal to 20. And now I'm going to go ahead and plug that into my quadratic formula. So x is equal to opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. So then in my calculator, I'm going to do the part underneath the radical first. And I'm not going to type the radical in. I just want to do what's underneath it. So in my calculator, I'm going to figure out 4 squared minus 4 times 1 times 20. And when I do that, I end up getting 1. So what is the square root of 1? Well, it's just 1. So I get negative 9 plus or minus 1 divided by 2. So now I'm going to split out my versions. I'm going to do negative 9 plus 1 divided by 2. Well, negative 9 plus 1 is negative 8. Negative 8 divided by 2 is negative 4. Then I'm going to do negative 9 minus 1, and then divide that by 2. Negative 10 divided by 2 is negative 5. So I got negative 4 and negative 5 as both of my answers, which means they both work. Both methods work. So let's go ahead and let's do this. Let's take a look at the graph. So if you look at this graph, so here's the graph of the quadratic we just drew. So what you notice is it's crossing the y-axis at negative 4, or sorry, the x-axis at negative 4 and negative 5. So that's what these parabolas, that's what the quadratic formula and factoring does for us when we're talking about the actual graph. So let's go ahead and let's take a look at number 2. So first thing we're going to do is solve it using the zero product property. So I'm going to set up the x. I'm multiplying to negative 24 and adding to 10. So to multiply to a negative product, I need a positive and a negative factor. So what multiplies to negative 24 and adds to 10? Well, that's going to be 12 and negative 2. So then I'm going to split up the 10x as 12x minus 2x minus 24 is equal to 0. Okay, so then what can you take out of your first group? Between x squared and 12x, you can take out an x. So you're going to divide each term by x. And then you're going to get x plus 12. Between negative 2 and negative 24, I can take out a negative 2. And then I get x plus 12 when I divide each of those by a negative 2. Just as a reminder, you always want to take out a negative greatest common factor if that sign in the middle is negative. So my leftovers are matching, so I can take out that x plus 12. So I'm going to go ahead and get rid of that. And then what's left after that is x minus 2. So now what I want to do is set each of those factors equal to 0. So x plus 12 is equal to 0, and x minus 2 is equal to 0. So for x plus 12, I'm going to go ahead and subtract 12 from both sides, and I get that x is equal to a negative 12. Then when I have x minus 2 is equal to 0, I can go ahead and add 2 to both sides, and I get that x is equal to 2. So my answer for this one is x is equal to negative 12 and x is equal to 2. So let's go ahead and let's try this using the quadratic formula. I do want you guys to be practicing both because you need to be comfortable using both methods. So my a is equal to 1, my b is equal to 10, and my c is equal to negative 24. So now what I want to do is I want to solve using the quadratic formula. So negative 10 plus or minus the square root of 10 squared minus 4 times 1 times negative 24. All of that divided by 2 times 1. So again, when I'm plugging this into the quadratic formula, I want to make sure what's underneath the radical is correct. Okay, so I type that into my calculator. So then, when I do that, I do 10 squared minus 4 times 1 times negative 24, and I end up getting the square root of 196 divided by 2. Well, the square root of 196 is 14, so I get negative 10 plus or minus 14, and that's going to be divided by 2. So first thing I'm going to do is negative 10 plus 14 divided by 2. So that's going to be 4 divided by 2, which is going to give me 2. That matches this answer. So far, so good. Negative 10 minus 14 divided by 2. Well, that's going to give me a negative 24 divided by 2, and that's going to be a negative 12. And that matches this answer. So that worked out as well. So let's go ahead and let's take a look at this back one. So first of all, the graph. I always forget about that. So when we're taking a look at the graph, you notice you're crossing at a positive 2 here and a negative 12 here. So that's, again, where those solutions lie. So let's go ahead and let's take a look at number 4, solving that using the zero product property. So first I'm going to set up my x. So I'm multiplying to negative 12 and adding to 3. What things multiply to 12? 6 and 2, 3 and 4. 12 and 1. None of those are going to add up to 3. So this is actually not factorable. So here's the reason why we're going through and showing you all of this. Sometimes the zero product property works and sometimes it doesn't. So if it doesn't work, you have to use the quadratic formula, or you at least have to try it. So for the quadratic formula, my a is equal to 2, my b is equal to 3, and c is equal to negative 4. That's a 4, clearly. So now I'm going to plug that into the quadratic formula. So I get opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. So again, I'm going to simplify just what's underneath the radical first. So I'm going to do 3 squared minus 4 times 2 times negative 4. And when I do that, I end up getting 41 divided by 2 times 2, which is 4. So what you'll notice is 41 is not a perfect square, which is why the zero product property didn't work. So I'm just going to put that in as a radical. So I'm going to do negative 3 plus the square root of 41 divided by 4. So the best way to put that into your calculator would be to do negative 3 plus the square root of 41. Then hit enter, get that answer, and divide it by 4. And when you do that, you end up getting 0.85. Again, calculate it along with me. Make sure you're doing it correctly in your calculator. If not, come up and show me and we'll take a look. Then I'm going to do negative 3 minus the square root of 41 divided by 4. So again, negative 3 minus the square root of 41, hit enter, and then divide it by 4, and you get negative 2.35. So here are each of your answers. You could not use the zero product property on that one. So when you look at your graph, you'll notice that it's crossing the x-axis at an irrational decimal, which is why factoring doesn't work. We have to have a perfect square on the quadratic formula in order for factoring to work. So when does factoring not work? So factoring doesn't work when the x cannot be solved. That means the roots are not rational or there is no solution. So this no solution. When is there absolutely no solution? So, no solution is when even the quadratic formula doesn't work. And the quadratic formula doesn't work if you have a negative underneath your radical. Make sure you did it right before you just say no solution. But if there's a negative underneath the radical, that's when the quadratic formula doesn't work either. So let's go ahead and let's just take a look at an example of a word problem. It says the FHS physics department is having a pumpkin flinging contest out on the football field for Halloween. One team's pumpkin has a trajectory that can be traced by the function h is equal to negative 16t squared plus 72t. Pick a method and find out how long it takes the team's pumpkin to hit the ground. So what I'm going to do is I'm actually going to use factoring. And not just the x, I'm going to go way back and use greatest common factor. So I asked myself, what divides 16 and 72? Well, 8 does. So I'm actually going to take out a negative 8. And I notice that each of these have a t with it. So I'm going to take out a t as well. So I'm dividing each of those by negative t's, or negative 8t. So I get positive 2t here, and then minus 9 is equal to 0. So I'm going to take and I'm going to set each of these factors now equal to 0. Well, negative 8 times t, I'm going to divide both sides by negative 8, and I get that t is equal to 0. Well, that's when it's starting on the ground, so t is equal to 0 doesn't tell me very much. And then I'm going to add 9 to both sides, and I get 2t is equal to 9. Divide both sides by 2, and I get that t is equal to 4.5, and then I'm going to go ahead and write seconds. Okay, because that's the time estimate that it's going to hit the ground, okay? So that concludes your note video for today. Go ahead and get started on your practice once you're done. Thanks for listening.